Good morning, class. Good to see you guys again this morning, and good to be back with you. I really can't see you, but good to be back for a short session in class this morning. And as we go forward in chapter 15, if you get your book out, go ahead and get ready and have your book ready, and we'll get started. I want to review some again this morning. So if you look at the board, I have a few things here that we can, let me get on this side, that we can review. And if you'll follow along with me, we've been talking about electric current. Let me get back on this side. Electric current, there's three parts to electric current. And the first thing you have to have is a source of a current, as we had talked about. And then the second thing is you have to have a conductor, something that conducts the current. And the third thing would be then the load, where that actually gets dispersed to the right places. And we had talked about that. In order to have electric current, you've got to have those three basic parts that you would need to know. We talked about different types of current. First, we have the closed circuit. That is where the current gets to flow completely through from the source all the way back through the wires, through the object, the electromagnet in this case, and then back out through the source again. That's called a closed circuit, where the electricity or the current keeps moving. Then we have what's called an open circuit. That's where there's a gap in the circuit somewhere. We talked about a switch there. We'll talk about that in just a moment. But a switch, or someplace there's a break in the current, and it will not allow then the current to go back through there. The other thing we talked about was a short circuit. That's where the current kind of overpowers and goes past the load and has a lot of power in the current. It can cause a short. It can cause maybe a problem or a burning of a fuse or something. It's called a short circuit, where it jumps and takes a shortcut, if you will. And we talked about a couple of ways of protecting these our circuits. And one is the fuse that you're familiar with, I believe. We talked about that, where there's a fuse that is put in place there, and is encased in glass, and then there's a little metal strip in there. And what happens is that as the current goes through there, if there's too much current going, it generates heat inside of that little tube, and then it melts the metal strip, and of course then it won't allow the current to go any further than right there. And we use fuses today. Also, we have circuit breakers. Those are what you have in your home, and they're designed for the same basic purpose. But what happens with the circuit breaker is that when the current gets too much, the circuit breaker is spring loaded, and that spring then will pop, or will cause a break in that breaker, and the contacts are released, and then the current can't go any further. And that is to protect your home and other places that we use them, our buildings. We use them and to help with circuit breakers. Now, the good thing about a circuit breaker is it can be reloaded. A fuse cannot be reused, and you have to go ahead and purchase another one. But you'll put it in there, flip the breaker back, and you're ready to go if it were to go out in your home. And we talked about producing light from energy, and talked about three different, we talked about 5 different ways that happens. One was the incandescent bulb, which is the incandescent light bulb that you guys have in your home and use. And we had talked about how that process works. And a lot of loss of energy in an incandescent bulb generates a lot of heat, and which does produce light, but a lot of the energy then, the heat energy, is wasted. Then we have the fluorescent lamp. That's what is used in most industrial sites, and of course in our school we have fluorescent lamps, and they have contacts on each end, and then when the current goes through there, it shoots the electrons down that tube with the gas that is inside of that tube, and it goes to the other end, and it comes back, and it keeps going back and forth, generating that those electrons moving generates heat, which generates light, and then that the inside of that tube is lined with what's called phosphorus, and that the electrons collide then with that coating and produce that white light that we have with fluorescent bulbs. Then we talked about the compact fluorescent lamp, or the CFL, and that is where through technology and experimentation they compacted that long tube fluorescent light into a small light bulb looking bulb, which has some winding alleyways kind of to it, some lines to it, and we're able to use that in our home. Same process, same thing, but the fluorescent lamp then is a lot more efficient than the incandescent lamp, and the compact fluorescent lamp, or the CFL, is even more than energy efficient than even the tube lamp, and that's through technology. And we've come a long way in the area, of course, of light. Talk a little bit about neon lamps, which they use for advertising, and different colors, and the light then can it has neon in it. That's why it's called a neon lamp. And you put other chemicals in there that can form different shades of light. Also, you can paint the inside or have the inside of that tube a different color, and it'll show up with the colors that we use today. Talk about LED lamps just a little bit there. Then yesterday, as we talked about producing motion from electricity, three things that we talked about were the solenoid switch, as we talked about that yesterday, the telegraph, and the relay. And we talked about the solenoid and how that works. Talked about telegraph, how unique that is, and uses current, electrical current, then to send messages from one place to the other through the telegraph keys. We talked about the relay, and another word for relay is switch. It's like a light switch. And so we had talked about those things. Then we talked about electric motors yesterday. In our last class, the last class we had, talked about electric motors, and we talked about the DC motor. And there's three parts to the DC motor. That is the armature, all right, which is an electromagnet, and then we have what's called a field magnet, which is the permanent magnet of this motor. And then we talked about the commutator, which allows then for the current to go through in on an alternating basis. DC motor is direct current motor, and in order for this for the motor to operate correctly, you need an alternating current, and so that's what the commutator is for. So three parts you would need to know would be the armature, the field magnet, and then the commutator. Now, in the AC motor, AC stands for, of course, alternating current motor. There's three parts to it. It also, and you have the armature, same thing, field magnet, which is your permanent magnet, and then they have what's called slip rings, which keep the wires from twisting and that kind of inside of that motor. And you notice it doesn't have a commutator, which causes the current to alternate, because with an AC motor, you already have alternating current. That's what AC stands for, or alternating current. Then we talked about some sources, then finished yesterday with a few sources of electricity. And as we talked about that, we talked about, of course, light, and we talked about friction yesterday, and that's an example that is lightning, of course. We talked about chemical reactions and getting light. We talked about motion in the magnetic field, which we've been talking about as we've been going through this. And then we talked about pressure pressure that produces light. An example of that is you've got on your grills, on most grills, you have a button that you push to ignite the grill, and you push it in and it pops and it gives a little spark, and then it lights the grill. That's an example then of a pressure being put on something. Of course, the pressure there is you push down on that button, that's the pressure, and it causes then that spark to go through there in your grill. Then of course we talked about heat and thermal electricity, which we have talked about in the past. So I just wanted to review a little bit before we get going this morning. So you go ahead and make sure you have your book out, something ready maybe to mark in your book, and we'll get started.